JavaScript is a powerful language. You'll find it pretty much everywhere on every website on the internet. It's revolutionized online content, but there's more reasons than you think as to why JavaScript is powerful. But what gives a language like JavaScript power? For me, it's all about the interpreter, or moreover, the prevalence of the interpreter, how and where it's used. As an example, we've probably all heard of JavaScript and Python and Java, which is obviously not to be confused with JavaScript, but have you heard of languages like F or R, D, or even stuff like Lego script? Well, likely these are less prevalent than the more mainstream languages that I've just mentioned, and that's down to how and where they're used. But with JavaScript, most people think of the web. Most people think of client-side JavaScript, the stuff that runs in your browser, which makes web content that you're looking at more dynamic. And the code is interpreted by your browser. So Chrome or Edge or Firefox or whatever executes your code in your browser environment. There's also server-side JavaScript as well. For example, you can use a JavaScript engine such as Node.js, and you can run JavaScript on the server as well as the actual client. And Node.js is an interpreter, and it can execute on your web server to control your client. But did you also know that JavaScript can execute natively on Windows? That's right, Microsoft has its own JavaScript interpreter built into every Windows installation, and what's more, there are two flavors, a GUI version and a console version. The GUI version is called WScript or Windows Script Host, and the console version is also known as CScript. These are actually really powerful interpreters. They're capable of executing other languages as well, such as VBScript, but that's getting into a bit more detail for this video. Because of this fact that Microsoft has a native interpreter, malware authors often harness this power and they write malware written in JavaScript, which can interact with your file system, your registry, can make network connections, and can even run commands on your computer. It's also a language which lends itself really well to hiding its true meaning. You'll often come across very convoluted JavaScript when you're browsing through perfectly legitimate websites online, because web operators, well, they like to minify the content in an effort to reduce the file size of JavaScript on your page so it loads faster. Take a look at this example from PayPal. As an example, this is not a very appealing piece of code to analyze because the function names are all just letters. There's no context to any of the code, and it's all actually squished onto just a single line. Of course, there's also the added benefit that if the code is tricky to analyze, they may be able to sneakily track you or do something else nefarious, and so adversaries will often harness these same tricks when writing their malware to hide and disguise their true functionality, leaving us malware analysts having to peel back many different layers before we uncover the true intention of the code. So today I wanted to share with you some insight into how I approach JavaScript malware analysis, and in particular look at a malware variant known as Retefe, or Retefe, or Retefe. We'll go with Retefe. From Malpedia, we can see the initial details about this malware and also get some great blog posts as well to refer us to, which helps our analysis. Retefe is a Windows banking Trojan that can also download and install additional malware onto the system using Windows PowerShell. Its primary functionality is to assist the attacker with stealing credentials for online banking websites, and it usually targets Swiss banks. So this is what the malware looks like. You can see it's pretty unreadable, and if we just scroll through the code, you can see in the middle here a call to eval. Eval is pretty dangerous. We want to get rid of that. So in the text editor, let's change that to wscript.echo. We can then take this file, we can put it in our virtual machine. We don't want to run it on our host. We can use CScript, the interpreter that will run this, to execute the code using wscript.echo, and we can just see the output. We can actually pipe that to a file, and what's output is another call to eval with another function. And we can just, again, rinse and repeat wscript.echo, and we can copy that file out as well. Let's replace that in our virtual machine, and let's run cscript again on that file, and let's just have a look and see what the output gives us. We can see here we get loads more code yet again, so let's just pipe that out to another file. Once it's written it to a file, we'll copy it back into our text editor here so we can take another look at it. And we can see right at the top again another call to eval, which we're just going to replace with wscript.echo again. So just get rid of that, wscript.echo, and we can take that file yet again, and we can put that back in our virtual machine, and we can run that yet again using wscript, or cscript in this case. Here we see we get yet more code. Let's pipe that out to another text file. Once we've got that in our Sublime text editor, we can then prettify that as well. We can see it looks like valid JavaScript, which is all good. It looks a little bit more readable, but we do need to beautify this code. And so what I like to do is use CyberChef again to beautify this. We can just dump it in a new instance here, and we can just select JavaScript beautify, prettifies the code for us, and we can now perform our analysis. So this malware's got a few tricks up its sleeve and some indicators we can glean immediately from this code, but let's just have a skip through it first to see what kind of jumps out at us with respect to functionality. We can see functions to write data to files, generate random numbers. Also, we can see some calls here to get my IP address, and a function called install pack, which takes a argument here which is base64 encoded. So let's decode that using something like CyberChef. CyberChef's nice and easy because we can create a recipe here to get rid of that string concatenation, so to do some simple find and replaces here to get rid of those, and then we can base64 decode the content as well, and that's going to reveal a registry location that this malware is going to be writing to. We can see here that equates to the internet settings auto detect. There's another base64 encoded string here as well. We can use the same recipe to decode that, and that equates to the auto config URL as well. And these are settings within the registry that are going to manipulate the proxy environment of the victim. Also, there's some stuff going on with the Firefox profiles, and also another part of the pack file manipulation. There's some editing going on here of the internet preferences to make sure that the .onion addresses that we saw earlier in the code are permitted, and also that certificates are trusted within the environment as well. We can see some other stuff going on with relation to base64 encoded content. Let's just decode that because that's what the recipe we've got going on. We can see if we decode those, they equate to killing tasks, namely Firefox, Chrome, and Internet Explorer. We can also see the malware is going to look to see whether or not CScript and WScript are running on the machine, which would indicate that this malware is already being executed. We've got these 4.onion addresses at the top, and we've got these blobs of base64 encoded content as well. One is called cert, so if we decode that, we can see that that in fact is a certificate, and this certificate is going to be installed on the victim's machine, so the adversaries can proxy all of your internet traffic and also decode your TLS content as well. So we can see this other variable PS, that's more code, and if we have a look at that code, there's a lot of stuff which again relates to certificates, also looking at running processes on the machine, all that kind of good stuff that you can go and take a look at. Okay, the next one is PSF. Let's have a look at this again as well, and if we just adjust this in CyberChef, we can see yet more code, yet more what looks to be .NET. We can see that in fact we've got some code related to certificates again. Next one, PSTP. Let's have a look again. It's using the same recipe. We can see that this looks like PowerShell, and if we have a look at this again and just apply some syntax highlighting to make it a bit more readable, we can see that this particular malware is downloading 7-zip onto the machine. Also as well, it's downloading the task scheduler module as well to set a scheduled task, which is going to be how this malware is going to remain persistent on the underlying victim's machine as well. We see all of the attributes of that Windows task. And we can see some calls to bitadmin here where it's going to download URLs passed to this particular function and save the contents to a file. And we can see actually what it's going to download here are actually the Tor binaries, and so the reason why the malware does this is because it wants to proxy all of your data over Tor, so it needs to have the Tor service running, and it's going to proxy that using this particular binary here called SOCAT, and it's going to set up a proxy listener to proxy all of your internet traffic through Tor back to the bad guys' servers, and they'll be able to intercept your TLS traffic using the certificate that we saw earlier as well. Okay, the final one, PSLog. Let's have a look at that using the same recipe, just tidy it up slightly, and we can then see again more PowerShell. So let's have a look at this in the window here with some syntax highlighting, and this is all about writing a log file which is uploaded to an FTP site. The credentials here are hard coded into the malware, so you can go and take a look at that if you wish, but you can see that the malware is tracking its progress. It's writing stuff to a log file and then uploading that log file to that FTP location, and that includes stuff like your antivirus products that you have installed on your machine as well. So there you have it. Today we've seen some super simple tricks that we can use in our lab environment to analyze these layers of malicious JavaScript so we can get closer to the original code that the adversaries don't want us to get to and see and examine, and we can extract as many indicators of compromise as possible, so then of course we can then go and best protect our environment. I really enjoy making these videos. I appreciate you being here as well. I like looking at novel techniques that malware uses, and if you want to get closer to my work and support this channel, well, I've set up recently a Patreon, and thank you to those who've already subscribed to my Patreon. It really does mean an awful lot to me. The link is in the description of this video. In my Patreon, you can get access to the most interesting stuff that I read around the cybersecurity industry, and more importantly, I tell you why it's interesting. And also as well, you can get access to my notes for these videos, and they often include some insights and thoughts and analysis that doesn't necessarily appear in the video as well. If that's your thing, I do appreciate you checking it out. Also as well, you can follow me on Twitter @CyberCDH. I really look forward to seeing you there. Until next time, take it easy.